Hello everyone, welcome to my YouTube channel Know About Embedded System. So in today's video we will understand why CAN protocol is used in automotive industry. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. So guys, you all know that already. What is CAN stands for? So CAN stands for Controller Area Network, and this is basically a protocol. So this protocol widely it is used in automotive system, and why we have to use that part we will understand. So guys, let us consider here one car. So you know that already in my previous video I have explained you in car we will have more than 15 different ECU, especially when you take with a high-end cars you will find more than 20 different ECUs, and these are all the different ECUs you can see, like airbags and then transmission controller, and then vehicle-to-vehicle communication, anti-theft, and so on. So at more than 20 number of ECUs you will find, and these ECUs are connected through a network. You can see the lines here. So in the previous video also I have explained these ECUs are connected through the connecting terminal or connecting protocol mechanism. All ECUs, if you have 20 ECUs, 20 ECUs will be connected via a protocol mechanism, nothing but a physical wired network. And this wired network can be designed using any one of the protocol you can see here. So we can use either CAN or CAN-FD. Preferably we will go for CAN-FD. This is the first priority of the vehicle manufacturers, to priority for the vehicle manufacturers because of its own advantages that I'll be discussing later. The second and third important protocols are FlexRay and Ethernet. So these three protocols, first is CAN, CAN-FD, FlexRay or Ethernet, are widely used in automotive industry in order to communicate between one ECU to other ECU. LIN is used, but not LIN is having its own drawbacks. That's why LIN will not be used as a full-time protocol, and LIN is used as only supporting protocols. So now we will understand two different scenarios why we have to use a CAN and why we are not using FlexRay and Ethernet. FlexRay and Ethernet also used, but FlexRay and Ethernet are very high speed communication protocols and very costlier they are. FlexRay and Ethernet both are very high speed, and they can carry the more bytes of data, and they are very costlier when you design an automotive system with the help of FlexRay and Ethernet. So CAN, even though it is costlier, but not costlier like FlexRay and Ethernet. So it is cheaper than any other protocol. That is one reason why we have to use a CAN in the automotive industry. Now let us consider here two scenarios why we have to use a CAN with one more strong reason. So if you consider any automotive system, I told you already we will have a more than 10 different minimum. We will find more than 10, and if you go for a high-end cars, it will go more than 20 different ECUs. So when you consider ECUs without protocol, or especially without a CAN protocol, if you consider, your ECU connectivity will looks like this. So this is you can see here, it's a point-to-point communication without CAN, a point-to-point communication in automotive system without CAN. So what will happen without CAN protocol? Each ECU has to connect to the centralized one common system that is called as a dashboard. This is a common ECU where all the ECUs are going to connect to this. Okay, and it will become more bulkier. You can see the wiring here, the connectivity, whatever you are seeing, this is very bulky, and we will also call as this wirings as a harness. More complicated harness, more complicated wiring you will find in the point-to-point communication without CAN. Each ECU has to connect to the dashboard and the two other ECU in a asynchronous way. So there is no proper mechanism to communicate from one ECU to other ECU. So this is how without CAN or without any protocol we can design our automotive system. This is a very old technology. We're not using this. So what is the conclusion with this slide is, we required on systematic protocol design so that all ECUs are connected in a systematic way without more harness. So very less harness or with very less wiring, we want to connect all the ECUs in a systematic way, and also all ECUs are given with a higher priority. So now let us consider one more scenario here. Automotive system with CAN protocol. You can use any protocol, but preferably we will use CAN because it is having its own advantage that I'll be discussing in the next slide. Now you can see here. So I have a CAN protocol. Now by using CAN protocol, I'm able to communicate. I'm able to connect all the ECU in a systematic way, and even to the dashboard as well. If you just compare the both the images, now you can see here, this is a very asynchronous and very complicated net. This looks like very simple in the image, but when you implement the same concept in the real time, it will become more bulkier and more harness and more complicated, and cost also will be more when you're using this type of design in your automotive system. So now when you go with a CAN protocol, all the ECUs are able to connect to the one common line that is called as a CAN bus. So we will have two types of buses in the CAN. You can go for a high speed communication, and also you can go for low speed communication. This is a very big advantage of the CAN protocol, why we have to use a CAN in automotive system. But whereas FlexRay and Ethernet, they are very high speed protocols, very high speed communication protocol. They are capable of transmitting a data at 10 Mbps, 20 Mbps, and 30 Mbps. But with the CAN, you can go with a 1 Mbps speed. What is the advantage? I'll just mention. You can go with a medium speed 1 Mbps. You can go high speed 10 Mbps, 8 Mbps, and you can also go with a low speed of 120 kbps, kilobytes per second. So this is a very big advantage of a CAN protocol, why we have to use a CAN in our automotive system. Based on your requirement, you can select high speed communication protocol. As I told here, this is a very high speed. This is called as CAN FD. We will use something called as CAN FD up to 8 Mbps, and then we will be having a standard CAN up to 1 Mbps speed, and we have low speed CAN up to 128 kbps. So this is a big advantages. You can connect your ECUs either on a high speed communication bus, or you can also connect your ECUs in a low speed communication bus on a single line, two lines. One pair of line we'll be using, and those are called as CAN H and CAN. We'll be using two wires here. One is called CAN H and one will be called as CAN L. We'll be using two wires. Using two wires, you're able to connect more than 100 devices. More than 100 devices you can, or 100 more than 100 different ECUs you can connect to only two lines. So when you are using CAN, wiring will be less, very cheap, cost effective, very dynamic, and very high speed communication also you're able to achieve with the help of CAN. This is a second major reason why we have to use CAN protocol. So systematically, with the two wires you're able to connect, and you can achieve high speed, medium speed, and low speed as well with respect to CAN. But that's why CAN is very popular in our automotive system. So we will understand some more reason why we have to use a CAN in automotive. The first major reason already I told you. So your CAN is going to reduce the wiring, and also it is going to reduce the cost. This is the first and foremost reason why we have to use the CAN. Why we're not using a FlexRay and Ethernet. As I told you already, FlexRay and Ethernet are very high speed communication protocol. They're not able to communicate when you're going with a low speed communication. And cost will be more when you go with a FlexRay and Ethernet. But when you use the same design with the CAN, the cost automatically comes down with respect to wiring and with respect to its design as well. This is the first major thing. Second major thing why we have to use the CAN, reliability and safety. The CAN is a reliable protocol, especially in the fault tolerant, whenever you're using safety mechanisms like airbags and braking system and engine management system. This kind of application you can use our CAN protocol in order to provide a proper safety mechanism, such as your fault tolerance. The CAN is capable of detecting the fault, and also it's able to send the error frames as well whenever there is an error. So how that I'll be explaining later. in the upcoming videos. The next third one is real-time communication. So I told you already, CAN is capable of sending and transmitting data at different speeds. So I told you 1 Mbps it is possible, and it is also possible at up to 8 Mbps, and also it is possible with 128 kbps as well. So real-time communication with a high speed, and dynamically you can transmit the data. So this is what I told. It enables the fast, efficient data transmission, and you can transmit 8 bytes, and also you can transmit 64 bytes as well. In CAN and CAN-FD, CAN able to transmit 8 bytes, and CAN-FD it is capable of transmitting 64 bytes with the different message IDs. Okay, yeah. Next point is data prioritization. So basically, CAN uses some message IDs, and based on the prioritization, we can use these message IDs. We'll be using something called as message ID. Data prioritization. So it uses something called as arbitration. You can see here. So CAN uses arbitration mechanism. So this arbitration mechanism will allocate the priorities to the different data transmitting messages. Each frame will have its own identification number, and based on your requirement of the priority, we can assign the priority to the message ID that will prioritize your data. That is the fourth reason. Fifth reason, scalability and flexibility. The CAN protocol will give you a more flexible feature. Without making a major change, you can design a new ECU. Whenever you want to design, or whenever you want to add a new feature to your ECU, with a minimal changes, we can upgrade your device to the next level. That is called flexibility. Easily, without changing major design, easily we can upgrade to the next level of your ECU. That's one more big advantage. And next advantage is centralized control system. That means CAN will not use any centralized system, but each device, each ECU is capable of taking a decision as a centralized system. So it is going to enable the distributed control system where each ECU can share the information and make the decision without any centralized host computer. So here there is no master and slave concept. Or in CAN, every device will be acting as a master, and each master is called as a node, and each node is nothing but one ECU. Each ECU is capable of taking any decision at any time, and according to the decision, we can control some of the functionalities. That is also one of the big advantages. So because of all these reasons, whatever I have discussed so far, because of all these reasons, CAN is used in automotive industry as a communication protocol in order to communicate between various ECUs in the vehicles. So I hope this video is clear to all, and if you feel this video is an informative video, please click on like button and subscribe my YouTube channel.